Hello team, in this video we're going to talk about how to manage distributed systems. So let's consider the system that tracks driver's license information in Brazil. In this system, we have one node per state, and each state keeps track of that state's drivers. For example, my driver's license is from Minas Gerais, so the state over here. And the nodes interoperate when they need to exchange information. So this design is reasonable because it's efficient if most accesses are local. So if most of the times someone needs to check my driver's license, I'm in my state, then the access will be local, which will have low latency, will use less network bandwidth. And the design is also general because if I travel to other states, then law enforcement in those states can also check my driver's license information. All right, but how do we keep the system running? So one thing that we can do is have local staff on each state that's going to take care of the node in that state. So if the node goes down, if there's a network or a hard disk failure, for example, the local staff can go and fix the problem. But if this is all we have, then it may take long to identify that there's a problem going on and for the local staff to fix it. So to make the response time faster, what we can do is have an automated monitoring system. And this monitoring system may probe these nodes periodically to identify failures, and when a failure is detected, then we can automatically notify the local staff. There are two things we need to decide here. So one is how frequently to probe these nodes, and this is a trade-off between liveness and overhead. So if we probe very fast, it's good because we're going to detect failures faster because we're probing very frequently, but it's going to incur network and computing overhead on the monitoring system and on the nodes because they're going to be probed all the time. So this is one thing we have to decide, and the other one is how to check that the system is working. And we can have, lightweight checks, or we can have more thorough tests. And again, we have a trade-off between thoroughness, or what types of failures we're going to detect with our probes, versus the complexity of implementing those probes. So let's check an example. So here, the controller is probing the node every 30 seconds. So this is going to detect failures reasonably fast, and we're going to notify the local staff so that it can fix it. And we can also evaluate different types of probes. So we can send a ping to this node, and the ping will check that the network is up and that the server is turned on. So we send a ping over the network, then we get a pong. So we just know that the server is up. We can send a simple request to the application. For example, a request that just asks, are you on? And then if the application responds to this request, then we know that the application is running. Or we can have an even more complex request that checks that the application is actually behaving as expected. For example, we can send a request how many driver's licenses are in the system right now, or how many accesses happened in the last 30 minutes. So if we make a more complex request, then we also check that the application is running and, for example, that the database is responsive. And the operator has to decide exactly what query is best to use. So here we might probe every 30 seconds and request the number of recent queries on the database so that we get a good idea of whether the application is behaving as expected. And when we detect a failure, we notify local staff so that they can go and fix it.